Today's lesson is going to build from yesterday's lesson. So we're continuing ratios with fractions, but now we're going to have word problems. So this note sheet will be going on page 13. Please add the note sheet to the table of contents. But before we get to this sheet, we are going to do some vocab that needs to get added to page 6. So the vocab will need to be folded and added to page 6. A complex fraction is a fraction where the numerator and denominator or both are fractions. So for example, we have one here where both are fractions, 1/2 over 1/4. On the right side, we have a simple fraction, so not a complex fraction because it's a whole number over a whole number. And when someone sees this, my thought for the characteristic is, wow, fractions on top of fractions, oh my, that's a complex fraction. This sounds like The Wizard of Oz when I think of it. The next vocab word is reciprocal. We use reciprocals in order to solve complex fractions. So if two numbers are reciprocals, they will equal 1 when they are multiplied. So for example, 2/3 times 3 over 2 would be 6 over 6, which is equal to 1. And 7, or 7 over 1, and 1/7 will multiply and equal 1. There's a non-example on the pre-written notes, but a good non-example would be opposite numbers. So like 2/3 and -2/3. Those are not reciprocals, they're opposites. And then the characteristic is recip, flip. So if you need a reciprocal, you flip the fraction. Or if it's a whole number, you make it a fraction and then flip it. Recip, flip. Okay, this one is not on the notes page, but it's an example so you can see how to set these up. After driving to work all week, a Prius has 7/10 of a tank of gas. At the end of the same week, a Dodge Ram has 1/4 tank of gas. Write the ratio of the Prius's gas tank to the Dodge's gas tank as a fraction in simplest form. So first thing, it's asking for the Prius and then the Dodge. So we're going to have Prius over the Dodge ratio. So that'll be 7/10 over 1/4. And just like we learned in yesterday's lesson video, in order to simplify this, we want the denominator here to become a 1 so that we no longer have a complex fraction. So before we're able to do that, though, we do need to make sure that the units match. So in this case, it's a tank of gas and another tank of gas, so the units are the same, so those cancel out. Now to get 1/4 to become a 1, we're going to multiply 1/4 times its reciprocal, 4 over 1. And in the numerator, we're going to say 7/10 times the same number we used over here, which is 4 over 1. And then we multiply across, or you can cross cancel. But if you don't cross cancel, you're going to get 28 over 10. We can divide by 2, and we get 14, a 14 to 5 ratio. And we do not change this to a mixed number because we want a ratio. In this case, the Prius would have 14 tanks of gas to the Dodge Ram's 5 tanks of gas. So this is over double the amount. Now this one is on the note sheet. It's pre-done, example 1. So we have an athlete runs on a treadmill for 4/5 of an hour. The athlete then lifts weights for 3/4 of an hour. We're writing a ratio of the running time to the weightlifting time. So you'll notice it's running to weightlifting as a fraction in simplest form. So running over weightlifting. So that'll be 4/5 over 3/4. So the order matters. Need to pay attention to the order. Also, it is hours to hours, so the units are the same, so we don't have to do any type of conversion. So all we're doing now is simplifying the complex fraction. So we take 3/4, multiply by the reciprocal to get it to become a 1. We take whatever's in the numerator, multiply by the number we used in the denominator to keep it equivalent, and then we multiply across. And so our answer is 16 to 15. So slightly more time spent running on the treadmill than lifting weights, and do not change it to a mixed number. A ratio is a comparison of two numbers, so leave it as 16 over 15. So here is the pre-done one on your notes page. You might want to circle and highlight specific things in order to remember how to set this up. Now this is the you try on your note sheet, and the missing value you need to fill in is 4. So recipe calls for 2/3 cup of water and 4 cups of chicken broth. Write the ratio for the cups of water to the cups of chicken broth as a fraction in simplest form. So please pause the video and try to set this one up before you watch it, and maybe even do the entire problem. Really try it. So it's asking for water to chicken broth, so water to broth. The water is 2/3, the broth is 4 cups. So we have cups and cups, in this case, less than a cup, and this one 4 cups, but still the units are the same, so the units will cancel out. Then we have 4/1, because we changed the whole number into a fraction, and the reciprocal of 4/1 is 1/4. And then in the numerator, we have 2/3 times whatever we change down here. So 2/3 times 1/4, multiply across. We can simplify this by dividing by 2, and we're going to get a 1:6 ratio. So for every 1 cup of water, there are 6 cups of chicken broth. In class, I gave a stretch break because these next problems get more challenging. So a model of a famous statue is 1.5 inches tall. The actual statue is 4 3/4 feet tall. What is the ratio of the height of the model to the height of the actual statue in simplest form? And we're going to write this as a fraction. So we have the model to the actual, because in the problem it says it wants the model compared to the actual. The model is 1.5 inches tall, and the statue is 4 3/4 feet tall. So we have inches and we have feet. So we have an issue because the units are not the same. So we're going to have to do a conversion. But before we can do the conversion, we need to change these mixed numbers into improper fractions. So 1.5, if we do our 2 times 1 plus 1 strategy, we'll get 3/2. And here we have 4 times 4 plus 3 for the numerator, so 19/4. So we've rewritten 1 1/2 as 3/2, and we've rewritten 4 3/4 as 19/4. And we have inches compared to feet. So we do need to change these into both inches. That's the preferred method. So we can multiply feet by 12 because there are 12 inches per 1 foot. So I've changed the conversion into a fraction so we can multiply across. I'm simplifying here because on the note sheet, I didn't, but on here I am, so you can see the difference, which is making the number smaller. So 12 divided by 4 is 3, 4 divided by 4 is 1. 19 times 3 is 57, 1 times 1 is 1. And the 3/2 stays 3/2 because it's inches to inches. This one we're changing into inches. Now they're the same, they cancel out. So to get rid of this complex fraction, we need to multiply by the reciprocal, multiply by the reciprocal, and we'll get 3/114. This can be divided by 3, and we'll get 1/38. So here it is on the note sheet, and I have the steps boxed. So step 1, set up your ratio based on the order in the problem. You have to, step 2, change these mixed numbers to improper. Then we need to do a unit conversion. Step 3, this one stays inches. This one's converting to inches by multiplying by 12. Here we need to do the reciprocal. I did not cross cancel on the note sheet here, so this is not cross canceling, but with a calculator this isn't so bad. So we have 3 times 4, which is 12, 2 times 228, which is 456, and then we have to simplify it. So highlight what you think needs to be highlighted. Okay, this is the you try. A professional football field is 53 1/3 yards wide. A poster of the field is 1.5 feet wide. Find the ratio of the width of the actual field to the width of the field in the poster as a fraction in simplest form. So pause the video and please try to start this problem. So key thing is we're being asked for the actual to the poster. So the actual is 53 1/3 yards, and the poster is 1.5 feet. So we have different units. So we're going to eventually have to do a unit conversion. So we need to change both of these into improper fractions. So we're going to have 160/3 all over 3/2. And remember, we have yards and feet. So we need to change our yards into feet. So There are 3 feet per yard, so we can do times 3 over 1. I cross cancel the 3's here. You don't have to. If you don't cross cancel the 3's, then you'll have to divide by 3 at the end of the problem. So because I cross cancel the 3's, I'm going to get 160 over 1. And then we have to do cancel the units and then simplify our complex fraction by multiplying by the reciprocal there. And then using that same value up here, move it up. We multiply across 320 over 3. And that is your final ratio. Now, if you didn't cross cancel the 3's here, you're going to have a 3 here. And you're going to have a 6. I'm making sure that that's the case. Actually, this number will be much bigger because it'll be times 3. That's what it'll be. This will still be a 2, so I apologize. But anyways, once you simplify, you should get the same answer. Okay, example 3. A recipe for a large batch of buttercream frosting calls for 1 1/4 pounds of powdered sugar and 2 ounces of whipping cream. What is the ratio of whipping cream to powdered sugar? So on this problem, the whipping cream needs to be first, but up here it's listed second, so you have to be careful. So the 2 is in the numerator and the 1 1/4 is in the denominator. So I have step 1 is the setup. Step 2 is putting the 2 over 1, or in this case, this one needs to change to improper. Then we have ounces and we have pounds, so we need to convert to ounces. This one's staying ounces. So 16 ounces per every 1 pound. I did not cross cancel the 16 and the 4, even though that would have been helpful. I left it here in case students don't cross cancel. So we're going to multiply by the reciprocal to get the denominator to become a 1. Here we're going to multiply by the same value we did in the denominator. So we'll get 8 over 80, and then you divide by 8 to simplify the problem. So please highlight things that stand out to you. Okay, this is you try number 3. A monarch butterfly has a total lifespan of about 8 weeks. As part of a caterpillar's life cycle, it spends about 9.5 days in the cocoon. What is the ratio of the time spent in the cocoon to a butterfly's total lifespan as a fraction in simplest form? So pause the video and please try to set this problem up. So you're going to have 9.5 days per 8 weeks because it asks for the time spent in the cocoon compared to the total lifespan. Change the 9 1/2 into a improper fraction. 8 weeks, you could write this over 1 here if you want. You don't have to because we're going to do 8 weeks is equal to how many days? Well, there's 7 days per 1 week. So you're going to get 56 days. And now the units cancel out. So because they match. So we're going to have 19 over 2 all over 56 over 1. Multiply by the reciprocal. 19 over 112. And since 19 is prime and does not go into 112, that is the final answer.